the 5E lesson plan. We're going to take a few minutes and look at the praxis questions. I did not get a chance to grade your alls yet, so maybe you can just remember what your answers were, and when I grade them, the feedback I give you is I tell you the correct answer for the ones that you missed. So I hope that helps. Okay. So questions. Number one has to do with a physical change. So here's how you can remember the difference between a physical and a chemical change. A chemical change cannot be undone. All right? A physical change can be undone. So let's go from the bottom up. Liquid mercury is boiled to get to a gas. That's a physical change because we could cool the gas back down and it could become a liquid again. Does that make sense? Okay. B, an iceberg melts in the ocean. That's also a physical change because we could freeze it again and it could become an iceberg again. A piece of paper is cut into hundreds of pieces. You might think that that would be something you couldn't undo, but you could take it back together if we wanted to, right? So that's another physical change. So the answer is C, an apple rots on a kitchen table. You cannot take a rotten apple and turn it back into a nice apple. So that's a chemical change that cannot be undone. Number two, Newton's first law of motion is that the answer is what affects the motion of an object while it is in motion? An external force. Once, like for example, think about a baseball game. They throw the baseball. The baseball's motion isn't going to change from that toss until the batter hits it. And then that external force of the bat changes the direction and of the ball. So the third question, there are actually 6 simple machines. And this is where, even though I have the questions here for you, you'll benefit from this praxis book that you purchased, because if you go in here, it has a really wonderful science review that starts on page 240. And if you look at page 268, it shows you those simple machines. So they are a lever, a screw, a pulley, a wedge, an incline plane, and a wheel and pulley. So when I scored these for my online class, question 4 and 5 were the most frequently missed. And really, to answer these questions correctly, you do not need to know anything at all about waves. All you need to know, and I would encourage you, whenever on the praxis you see a question that has a chart or a graph or a table, focus on interpreting it instead of using the content knowledge you have, or use that with it, obviously. But the question says the wavelength of a microwave. So here's a microwave. On the bottom, it's talking about wavelengths, and up here, it's talking about frequency. So it says the wavelength of a microwave. So microwave is here, and we're looking at the bottom. Wavelength is approximately 1 centimeter. Which of the following lengths could represent the wavelength of a radio wave? So a microwave is here, a radio wave is over here. And if you read the chart, it says that going left, they're longer, and going right, they're shorter. So even if you don't know anything about radio waves or microwaves, the only number down here that's bigger than a centimeter is a mile. So that is the correct answer. The only possible wavelength that's bigger than the microwave is D, a mile. And then, similar over here, the frequency of an X-ray. So, an X-ray is here, and we're looking at frequency. It says that they're lower to the left and higher to the right. So it says the frequency of an X-ray is 10 to the 18th. Which of the following could be a gamma ray? So this is 10 to the 18th. So since a gamma ray is to the right, it needs to be bigger than 10 to the 18th. So there's only one answer that's bigger than 10 to the 18th, and that's 10 to the 20th. So the key is, the idea is, use the tools that they have, the charts that they give you. So Einstein's theory of relativity. You might not know anything about Einstein's theory of relativity, except you've probably seen this on a t-shirt or in a movie or something. You've seen this equation, right? So you might have no idea what this means, but I remember the c squared. So when I see Einstein and I think of E equals mc squared, the only one of these that has a squared, that's how I would deduct that answer. Potential energy. We're going to talk about potential and kinetic energy today. Potential energy is not in motion. Kinetic energy is in motion, so potential energy is stored. An ocean wave crashing is a movement, so that's kinetic energy. A sound wave echoing is movement, so that is kinetic energy. A microwave heating is moving, so that's kinetic energy. But a rubber band pulled, if you have a rubber band and you pull it right here, it's not moving yet. As soon as you release it, then it's kinetic. So that stretched rubber band is the potential energy. And the simple machine, which one is not a simple machine? I'm sure you probably put calculator. So what is your, you've done 2 pages now, what is your impression of these questions? Easy, difficult, about what you expected, harder than you expected, easier?
Some of the questions you have to think harder about, just like remember what they're asking. That's a long time ago.
Okay, so a lot of it you probably have heard before, you just need to remember it, okay? All right. Okay, well, the goal is to help you study and to be prepared. All right, so Tuesday, we went through part of the lesson plan. We went through part of the 5E format. So if you would get out those 2 handouts, we're going to continue on in that today. So what's the first E? Engage. So somebody on this side of the room tell me, what is the purpose of an engage part of a lesson? The purpose of an engaged part of a lesson. This side of the room.
It kind of like generates interest in what you're about to teach and have the students do.
Yes, generates interest. That's exactly how I would summarize it. So, someone on this side of the room, what is the main role of a student?
Respond to questions.
Respond to questions. Okay. Hopefully get interested, right? What's the main role of a teacher? Or characteristics? what's the role of a teacher in the engage?
They need to raise questions and then generate interest and curiosity.
Okay, so give me some examples of engage things that you could do to engage. A book,
A short little game.
a short little game, videos, ask questions, link to what they already know, right? Okay, so is an engage part really, really long or probably pretty short? Pretty short, good. So the second E is, so whereas the engage is really, really short, I think I told you all, this is where a lot of your time should be, right? Okay, so tell me what is the purpose of the Explore? Somebody at, let's see, I've already heard from Savannah. So Haley, what can you tell me about the Explore?
You do activities and collect data to make sense of the topic. So you make hypothesis and discover.
Yeah, discover, make sense. Sometimes you're collecting data. Good, so that's what's happening in Explore. So, Abby, what is the role of a student in the Explore?
To think creatively, solve problems, and share ideas.
So, would having a student read a textbook fit the criteria of Explore? No, but I've had students turn in lesson plans where basically they took just a regular old boring lesson plan that they would have done anyway and just divided it into 5 sections that really did not look anything like what we talked about. All right, Meredith, can you tell me what's the role of a teacher in the Explore?
They are the facilitator and they're observing, seeing, and listening to students.
Good. So should a teacher be lecturing for 30 minutes in the Explore? No. Okay. So that's where we left off. And remember, it's perfectly fine in a 5E lesson to not finish it in a day. Okay? So we were collecting data in our Explore. Remember, we all had different soft drinks. And, so in our Engage, we looked at the cold day versus the hot day and how can we keep that soft drink cool. So then in our Explore, we collected data for 20 minutes on different coverings and which one kept our soft drink coldest the longest. And then we ran out of time at the very last second. So now I want you all to calculate the difference from your 20-minute time, or your 20-minute temperature to your, at the beginning, your initial temperature. So let me know what that is so we can draw some conclusions and we'll finish our Engage. Which one is? Koozie? Last, oh, no,
The clock and sock is 5.0.
okay.
Plastic wrap is 4.7.
Thank you.
The aluminum foil is 4 degrees.
Okay.
The paper towel is 4.3.
The wool sock was 5.
Okay. And
Should be 6.9.
thank you.
6.9.
Okay. So here's one of the things you're going to learn when you teach science. Remember I told you all that the pendulum lesson that we did, you all were the first class to get the most accurate answer. In this, what I would have expected to happen is not necessarily the result that actually happened. So based on this data, what is the best covering for a soft drink?